Hi, everyone. Thanks for joining my session today. And my name is Xiaoyi Li. I'm currently a lead cloud engineer at Pax Technology, and I'm also AWS community hero. And today, I want to introduce an agentic AI multi-agent system to help you do the threat modeling from just a single diagram, system architecture diagram. And let's see how does it work. This is a comprehensive agenda for my session. I will firstly introduce why we need to do the threat modeling, and what's the common challenges in the threat modeling, and how to address them. Next, we will come to the key content of this session. That's a tool, AI-powered tool to do the threat modeling. And I will introduce how does it work, and what's the architecture for this solution. And in the end, we will go through a practical tool, practical demo to know how to use this tool. And first, let's explain why we need the threat modeling. The threat modeling is to identify the threats in the early of the SDLC, and we can prevent it from becoming the true problem. And skipping the threat modeling can cause very bad impact to the system, such as the data breaches, the system outages, and some brand image. Next, the shift left matters. If we can detect and fix those threats in the early of the SDLC, we can reduce the security cost by up to 150 times. And the threat modeling is also a very critical requirement in the popular compliance requirements. For example, the PCI DSS 12.3.1 requires us to do the risk assessment and threat modeling per year. And threat modeling is also a best practice highlighted in the AWS well-architected framework to design a very secure system. The ID is SEC01-BP07. And if we can use the threat modeling to shift the security to the left in the SDLC, we can create a security by design mindset in our organization. That sounds very great, but when we do the threat modeling in our real life, it's very challenging. The main challenges I hear from the community developers and the organizations are following. The first, the AI brings the new risk to our real life, to our security work, such as the prompt injection and model poisoning. We need a framework to identify and mitigate those new AI risks. And the threat modeling is also a manual and a time-consuming process. I still remember when we do the threat modeling, I sit with our CISO and the member across different teams and spend a lot of time to complete a great threat model. And the threat model also easy to be static and stale. When the system changes, the previous threat model become outdated. And last one, because the developers always has very tight delivery schedule, so they always defer the security and do the threat modeling in the late of the SDLC. Next, I will introduce how to address those challenges. First, besides the traditional threat modeling framework, such as STRIDE, which includes the spoofing, tampering, and information disclosure, we can use the new AI threat framework, OWASP Top 10 for LLM. And we can use AI to light the threat modeling to become an automated and streamlined process. And threat modeling also need to be a continuous and dynamic process. When the system evolves, we need to get the latest threat model in real time. And if we can use AI to light the threat modeling process, easy to adopt, the organization will embrace the security by design mindset. And the tool to address those threat modeling challenges is Threat Designer. Threat Designer is an AI-driven agent designed to automate and streamline the threat modeling process for security system design. It has the future features. Because we integrate the OWASP framework, so we can use that to support AI threat identification. And we can use the tool to automate and streamline the threat modeling process from only a single system architecture diagram. And this tool also transforms the previous static threat modeling process to a dynamic one. When the system changes, we can get the latest threat model in real time. And because the tool can shift the security to the left, it also mitigates the threats when we only have a design proposal. We can identify and mitigate those threats. And I will explain how does it work. It's very typical multi-agent system design architecture, and you can use that for other use case. I will explain the process from the left to the right. The input of the workflow is the required field is only a system architecture diagram, and you can also add a contextual background, such as the system description and assumption to the input to improve the threat modeling accuracy. And this workflow is built with the long graph framework and contains 5 nodes. The first one is image processing node. In image processing node, the node will analyze the image, the diagram you uploaded, and extract the key information using the AI vision capability. And when we come to the assets node, this node lets you know what do you have in your system. Then we come to the flow node. In flow node, the agent can help you get the data flows in your system and help you get the trust boundaries. And based on all above results, the threat node can let you know what you could do wrong in your system based on the OWASP and STRIDE framework. The last node in the workflow is the continue node, is a conditional node. If the AI agent will determine if you already create a very great threat model. If so, the workflow will come to the end. If not, the continue node will forward you to back to the threat node and regenerate the threat modeling. The output of this workflow are 3. The first one is some basic information for system, such as asset, data flow, trust boundaries. And second one is the detailed threat list based on the STRIDE and OWASP framework. It also can give you the AWS-based mitigation solutions and the red teaming solutions. This workflow have 2 modes. The first one is the standard mode. We need to go through all 5 nodes to get the threat models. And the second one is the replay mode. When you change your system, you don't need to go through all the nodes, and the AI agent can resume the previous results and skip the preceding nodes in the workflow to get the final threat model. We also can set the iterations and the reasoning token for this process to improve the accuracy. This is the overview architecture for this solution. It's a serverless one and fully deployed on AWS. And in a few next slides, I will dive deep into different parts of the architecture and tell you how to build a practical solution. We use the React framework to build the UI and host the UI on Amplify. And we use the Amazon Cognito for authentication and authorization. All the API calls go through the API gateway and are sent to the backend through the proxy integration. And this solution has 2 methods to trigger. The first one, you can create a threat model on the UI. Then the second one is when you push the IAC code onto the GitHub repo, the GitHub action will trigger the threat modeling process. We use a Lambda function to build the backend. The first function manages the current operation for the threat model, such as list threat model and edit the threat model. And the second Lambda function defines the multi-AI workflow logic. The third one has the chatbot to help you chat with the STRIDE models. For the database, we use the DynamoDB tables. The first one stores the agent execution state. So all the nodes in the workflow can share the same memory and the same state. And it also helps you do the replay, the STRIDE modeling replay. And the second table stores the metadata of the STRIDE models, such as the ID, name, and status. So you can get an overview of all the STRIDE models in your system. And the last one stores the chat history with the STRIDE models. For the AI model, we use the Cloud 3.7 Sonnet on the Amazon Bedrock through a Converse API. The unified API can simplify the GenAI application development, and you can use that to easily upgrade the model to the cloud for all Sonnet. And we use the pre-designed URL from Amazon S3 to securely upload the diagram to the S3 bucket. And this also offload the image upload from the backend to the front end to reduce the workload on the backend. We also integrate the demo with the Jira, so the team in your organization can stay on the same page and check the STRIDE modeling very easily. Next, let's go through the demo and see how we use the tool. To create STRIDE models, we just need to fill several fields. For example, the name, and you need to upload a system diagram. And you can upload an IEC code file if you want to let the tool to have a stress check. And you can toggle the OWASP framework if the application is a GenAI application. And you also can set the iterations and tokens for reasoning to improve the accuracy of the results. And those are the required fields, and you just need to click Start and start the STRIDE modeling. The STRIDE modeling is processed by 5 nodes in the workflow. And the results is like that. For example, we have a prompt injection attack, which is mapped to the OWASP framework, LM01. More importantly, you can get a very detailed AWS-based mitigation solution. You can see the second line in the mitigation. It suggests us to set up the Amazon Bedrock guardrail to do the input security validation. And you also can get many other detailed basic information in this page. Besides the above results, we also can use the chatbot to interact with our STRIDE models. We can use the chatbot with the predefined sample prompts to generate the remediation plan with the complete and secure IEC code file. You just need to copy the IEC code file and set up your secure AWS environment. For those people who want to do the red teaming validation, you also can use the chatbot to do the red teaming exercise with multiple models provided by the Amazon Bedrock, such as the Cloud, Amazon Nova, and DeepSeek. And in the end, let's review the key takeaways of this session. The tool is an automated, streamlined, and scalable multi-AI system. And we transform the STRIDE modeling from a static process to a dynamic. When the system evolves, we can get the latest STRIDE model by just click the Start button. Because we also add the OWASP framework to this demo, so it is aligned with the novel AI-specific threats. Because the tool also shifts the security to the left, so we can create the security by design mindset among our organization and identify the threats and mitigate them in the early stage of SDLC. The chatbot capability of this tool provides a conversational mitigation and red teaming solution for us. In the future, we will keep improving this demo and utilize the AI agent to simulate the red teaming exercise and do the self-healing for our system. This is the project on GitHub. You can scan the QR code to get the project. Please note the version on the GitHub is slightly different from the version I present today because I made some modification based on my organization's requirements. I will leave on this slide for several seconds. And in the end, thanks for joining this session, and I hope you can enjoy this session. I also hope you can open up your mobile app to leave the feedbacks for this session. I really appreciate it. And that's it. I will hang out there, and if you have any question, you can reach out to me. Thank you.